Hi everyone. This video covers the first update for my anime shader. The main focus of this release is addressing an issue I mentioned in the release video, which was meshes not receiving shadows from other objects. I've also included several new features and adjustments based on my own testing during this update's development. Since this is an unlit material, it doesn't natively receive environmental effects like shadows. To solve this, I've introduced two new methods, a blueprint-based detection system and lit material alternatives. First, let's look at the blueprint system. If you open the updated materials, you'll see a new section called Blueprint Parameters. These are designed to be driven by a script rather than edited manually. To make this work, open your character's skeleton. Right-click the joint where you want the light detection to occur and add a socket. I recommend placing it slightly above floor level to avoid unwanted shadows from the ground. In my case, I've placed it at the pelvis. Name this socket exactly. Socket Light Detection All. Next, create a new blueprint actor and add your skeletal mesh to it. To activate the shadow logic, go to Class Settings and change the parent class to BP Character Master. This master blueprint contains the necessary code. Now, when you place this actor in a scene with a directional light, it will detect if an object is between the light and the socket. If the socket is occluded, the material will automatically darken to simulate a shadow. Currently, this is a binary on or off effect across the entire model. The second solution is a lit material workflow. I've included lit versions of the master materials in a new subfolder. The advantage here is that your model will naturally react to all world lights and shadows. However, remember that atmospheric effects and light colors will now tint your model. To keep your colors accurate, I recommend using neutral light colors to calibrate your textures first, then adjusting your lights once the base look is set. I've pre-calibrated these materials to match the original unlit version closely. If you need to fine-tune the look for your specific scene, check the lit material calibration section. Here, you can independently adjust the brightness of both the base color and the emissive outputs. For example, if you want darker shadows, you can reduce the brightness of the emissive and increase the base color brightness. Specifically for the skin shader, since the shader handles color differently than the other, I've added extra hue and saturation parameters. This allows you to fine-tune the output and bring back the vibrancy or specific tones of your original color. Quick tip: if you change a material instance's parent to a different master material, your layer settings may reset. If you intend on changing the master materials on your models, I highly recommend saving your settings as a preset, like I did, or taking notes of the settings before switching. While testing the shadow updates, I experimented with several ways to handle skin rendering, as it often requires a different approach than other materials. The skin shader from the initial release wasn't actually a fully unlit material. It was a hybrid that reacted to certain scene effects while others didn't. This sometimes made it stand out inconsistently against the other unlit materials. To fix this, I've developed a few different solutions depending on your workflow: a fully unlit technique, an updated version of the original shader, and a new shader using Subsurface Profiles. Subsurface Profiles are Unreal's native way of handling realistic skin, but with the right adjustments, they can work for a stylized aesthetic. This method is great because it doesn't require a thickness map, though it does require a subsurface profile asset. I've included a base profile in the common folder to get you started. If you want to create your own, simply right-click in the content browser and select Materials, a Subsurface Profile. To apply your custom profile, open your character's skin material instance and scroll to the bottom. Under the Material Property Override section, you can override the default subsurface profile with your own. If your character is in a blueprint, the material might not refresh right away. A workaround is to save your material, then reload it. When tweaking these, I recommend focusing on 3 main settings. Mean free path color. The color light becomes as it travels through the skin, usually red or peach. Mean free path distance. The strength of the glow. Higher values look waxy, while lower values keep the skin looking solid. World unit scale. This depends on your asset scale. If you notice noise or artifacts on the skin, try lowering this value. For those who prefer to avoid skin shaders, I've implemented a second method that simulates subsurface scattering. This is based on a technique often used for vegetation to create efficient translucency, which I've adapted for characters. It is available in most materials, including both lit and unlit versions. For the best results, I highly recommend using a thickness map in the SSS mask slot to prevent the effect from spreading too far across the surface. As a reminder, this is a grayscale texture that determines which parts of the mesh are thick or thin. It can be hand-painted or generated. If you are baking this texture directly from the low poly, I recommend subdividing and smoothing your mesh first. Otherwise, the low poly geometry can cause unwanted artifacts in the final mask. SSS color. This is the light's exit color. It's mixed with your directional light color, so a sunset will naturally warm the effect. SSS mask strength and contrast. Use these to localize the effect to thin areas like the ears. Light wrap spread. This controls how far light wraps around the mesh toward the camera. SSS intensity. The overall power of the effect. Rim brightness and fall off. These control the grazing light on the edges, helping the character pop and simulating the tint subsurface scattering gives to the skin. If you are using a layered material, these settings are in the details section. I've kept the subsurface parameters global to ensure they turn off correctly in shadows. If you are using RGBA masks, each activated channel allows for a different subsurface color. Finally, the simulated subsurface effect is also influenced by the blueprint setup we saw earlier. Even when using a lit material, placing it in the blueprint will allow the detection logic to manage the subsurface effect intensity. I have also added support for shadow meshes. This is a great way to optimize performance by using a lower resolution version of your model to cast shadows. It also allows for creative freedom. You can use any mesh shape you like to cast a unique stylized shadow that differs from your main model. The setup is straightforward. Import your shadow mesh. If it's a skeletal mesh, I recommend using the same joint structure as your main model, so the animations stay in sync. Place the shadow mesh inside your character's blueprint. You can keep it as a separate component, or make it a child of the main mesh for better organization. Disable the shadow casting from your main mesh to avoid having both meshes cast shadow. Apply the new master material, MM Shadow Mesh, to the shadow mod. You don't need a material instance here, as it doesn't require any parameter adjustments. To make the shadow follow your animations, go to the event graph of your blueprint. Drag in both your main mesh and your shadow mesh. Create a set LED pose component node, connecting your shadow mesh to the target and your main mesh to the new leader bone component. Hook this up to the event begin play, and your shadow will now perfectly mimic your character's movement. There have been some changes to the character setup as well. I have now exported my characters as skeletal meshes. If you use Rigify in Blender, exporting can be a bit of a headache. I found a tool called Game Rig Tools that fixes the Rigify hierarchy for game engines, and I highly recommend it if you're facing export issues. If you already own the shader, I recommend updating all folder, as many assets have been updated or reorganized. The master materials folder now contains the updated unlit versions, while the new lit versions, including the new skin material, are located in their own subfolder. I've moved the skin shader to the new lit folder to keep the organization clean between lit and unlit materials. I've left a legacy version in the original folder so your existing projects don't break, but I highly recommend swapping over to the updated copy in the lit folder, or exploring the other new skin materials, since there is now more than one way to achieve the look you want. I have added the blueprint master to its own dedicated folder for easy access. Inside the character folders, you'll find the main skeletal mesh, the shadow mesh, and an animation file for testing. I've also included a subfolder for layer presets of this character, allowing me to easily share settings between the lit and unlit versions of the meshes. Important note, I've simplified the lighting edge blur section. I removed several unused parameters and renamed the max slider to lighting sharpness. This makes much more sense for the workflow, but please note your current max settings before updating, as you may need to readjust your sharpness values. I've removed the individual emissive settings from the layers. As I mentioned in the previous video, pushing a color value's brightness above 1, whether in the specific layer or the global section, yields the same visual result. Regarding known issues, if you use the layered setup on a skeletal mesh and edit the master material, you might see a warning about too many UVs. This is a native limitation of skeletal meshes in Unreal. I tested optimizing the layers to remove this warning, but it lowered the mask quality significantly. Since my priority is visual fidelity, I've decided to leave the system as is, as it will not affect the visual. For the next steps of this project, I'll first be focusing on a few videos I've had planned for a while. After that, I want to experiment with anisotropic hair for the shader and explore cleaner alternatives for the lighting blur to reduce the current granular effect. Finally, I've opened a Discord server for technical support on this shader and my other tools. It's open to everyone, but if you own the project, you can send me an email with the address you used to download it, and I'll give you access to the member-specific channels. It's a brand new community, so it's a bit quiet right now, but I'll be there to answer questions as quickly as my schedule allows. I think that covers everything for this first update. Thank you for watching.